Hanging like a target in the shooting gallery of our universe, the Earth lies vulnerable to many destructive forces. While we spend much of our time worrying about problems on our own planet, scientists are beginning to realize that the greatest risk comes not from threats on Earth, but from outer space.
Planet doomed to destruction.
They're gonna hit us! They're gonna hit us!
The nations of the world mobilize their armed might, rushing to defend the Earth against the unknown weapons of the super race from the Red Planet.
Planning much for Thursday the 26th of October 2028? Well, make sure you get it all done before 6:30, because that, according to scientists in Texas, could be the end of the world.
The Earth is constantly under threat from space. Asteroids that could destroy continents, sunstorms that could devastate satellite communications and electricity grids, and even extraterrestrial bacteria that could one day threaten Earth's fragile biosphere. Billions of dollars a year are spent on preventing global catastrophe through war, famine, or disease. But attention is beginning to turn to the destructive forces beyond Earth. As we learn more about the universe we live in, so are we becoming more aware of the many dangers that Earth faces from its space environment. Once the stuff of science fiction, governments across the globe are now allocating greater resources to protecting our Earth. Slowly, a group of people have emerged as the front line of planetary defense. Spanning the globe, they have all devoted their lives to protecting the Earth from the unseen threats from outer space. But perhaps the biggest threat to our planet has been the recent discovery of the danger that asteroids and comets pose to our Earth.
There is something like a 50-meter collision every 100 or 200 years. And that's large enough, depending on its composition, to cause considerable devastation locally on the ground.
The probability of being killed as a result of an impact by a kilometer-sized asteroid is comparable to that of dying in an aircraft accident.
It isn't if there will be an impact, it's when there will be an impact.
Our solar system is often seen to be a vast empty space, populated by a few planets. But it is actually teeming with rocks and comets. Galactic space debris, asteroids are the remains of unformed planets that have mostly collected in an asteroid belt between Mars and Jupiter. Occasionally breaking out of their orbits, these giant boulders of rock and metal fly randomly through the solar system, colliding into planets and other asteroids with destructive results. If a 2-kilometer asteroid were to strike the land, the crater would measure more than 20 miles across. With the explosive force of 2 million nuclear warheads, enough debris would fill the sky to block out the light for months. If the asteroid was to impact an ocean, it would produce a tidal wave so high that it would engulf the major coastal cities around our planet.
Back in 92 or 93, there was an object that exploded rather high that was on the order of 100 kilotons.
So large was the explosion, the US military thought it was a nuclear blast and was put on full alert. Back in Washington, President Clinton was woken by senior advisors, fearing the onset of a nuclear war. It was a timely reminder of the threat asteroids can pose. Los Angeles, California, the location for the Jet Propulsion Laboratory, the headquarters for NASA's Near-Earth Asteroid Tracking Program. Heading the team is Eleanor Helen, who has spent her life searching for Earth-threatening asteroids. She has seen asteroid detection change from an obscure science to the stuff of news headlines and subject to the Hollywood treatment.
When I started in the early 1970s, there were only about a dozen what we call Apollo asteroids at that time. Half of those did not have good orbits and we could not relocate them. So when you consider we have over 1,100 near-Earth asteroids now, you can see what has transpired.
During the 1990s, raised public awareness of the asteroid threat prompted the US Congress into action. Realizing that there was not just a possibility of an impact, but a probability, the government started to take the threat seriously. In response, NASA has begun an ambitious search program to find 90% of the estimated 1,000 asteroids, a kilometer in size, that could one day threaten our fragile biosphere. NASA's NEAT telescope is based 1,000 miles away in Hawaii. The asteroid readings are downloaded to Helen's computer at her office in Los Angeles, where she looks for brighter, faster-moving objects that have broken away from the asteroid belt and have become a theoretical risk.
Ken, have you looked at this further?
No, I stopped at 46.
Now that's a bright object, as you can see, and it's, well, 17.6. Do you agree? This, it seems to be duplicating, no. So I think so we won't keep that one. Ken and I, if possible, will try to do this together because sometimes, as I say, there is uncertainty, there's controversy. And sometimes, even at distance, our program manager will disagree with our selection or whether this is real or not, and we'll go back and forth.
She sends this information to Brian Marsden at the Minor Planet Center in Boston, Massachusetts. He is the key player in modern asteroid research. Together with his researcher, Gareth Williams, he collects all the asteroid and comet sightings made around the world and publishes them on the internet. Pulling together this information is a huge challenge for the astronomers.
We're putting out about 2,500 pages altogether per month. And it's increasing all the time because there are bigger and better telescopes.
One such published finding caused a global media storm.
I'm amazed they found it.
On March the 12th, 1998, Brian Marsden published his projected orbit for an asteroid identified by the US Spacewatch observatories on Kitt Peak Mountain, Arizona. Surprisingly, he estimated that an asteroid more than 1 kilometer wide could come extremely close to the Earth in 30 years' time. An asteroid that size would send us back to the Dark Ages. Astronomers called it 1997 XF11. Not surprisingly, the story made headline news around the world.
A mile-wide asteroid known as XF11 is heading towards Earth. If it hits us, well, we're more or less done for.
If it is within the realm of science to do something that we've never been able to do before in order to protect the Earth, certainly science should rise to the occasion and grasp that opportunity, and I'm sure that's what will be happening.
This was a sort of a watershed experience by actually having calculations to show that an impact was possible as a result of a moderately close approach to the Earth, and then the uncertainty in the orbit was such that you could get an encounter later on, a hit later on.
As the worldwide media worked itself into a frenzy about the potential threat, Behind the scenes, Marsden was urging NASA to look for earlier sightings.
It would have to be a big one to put an end to the human race, but even a smallish one, half a kilometre, would do an awful lot of damage, and a very large number of people would be killed by it.
Scientists now know that large asteroids and comets have impacted the planet in the last few million years. They now think that 65 million years ago, a giant asteroid struck the Yucatan Peninsula, leading to the extinction of the dinosaurs. More recently, in 1908, an asteroid or comet 50 meters wide exploded over the uninhabited Tunguska region of Siberia, flattening thousands of miles of forest. It could have killed hundreds of thousands of people. Not wanting such a catastrophe to happen again, NASA found an earlier sighting of the asteroid and set about refining its trajectory. Much to their relief, the new figure showed that it would actually miss the Earth by a comfortable 600,000 miles. Although to astronomers the whole media circus was unwelcome, it did bring home the threat to the wider public. It is no longer a fictional threat confined to 1950s B-movies. Finding 1,000 1-kilometre-sized asteroids is a major task. For a while now, astronomers and scientists, like Grant Stokes, have been concerned that by using current search methods, it wouldn't be possible to find all this within a decade, as required by the US Congress. So, 3 years ago, a new super telescope was built by the US government to help meet the target figure. Based at the old atom bomb testing site in New Mexico, this new project, named Linear, has detected nearly 10,000 rocks from the main asteroid belt and 40 of the crucial 1-kilometre near-Earth objects. The telescope has showed a capture rate unparalleled in this field of science.
During the night, this telescope is scanning across the sky to find all the moving objects which are asteroids or comets.
Linear's computers automatically detect the asteroids.
Over a period of 2.5 hours, we take a series of 5 frames. There's 1, 2, 3, 4, 5. The stars, over the period of the evening, do not move. The asteroids do, so that's how we tell the difference between the stars and the asteroids. And now the computer is off processing those to extract all of the moving objects. And it comes up with a set of objects that are moving here. These are potential near-Earth objects, and in fact, both of these are near-Earth objects that have been discovered by Linear.
Even relatively small near-Earth objects could have a devastating effect. Every 100 years, an asteroid big enough to destroy a major city strikes the Earth. But what good will identifying these rocks do without being able to defend ourselves against them?
3, 2, we have engines started. We have ignition. We have liftoff of the Delta rocket carrying the nearest spacecraft bound for the asteroid Eros.
On the 17th of February, 1996, NASA launched the Near-Earth Asteroid Rendezvous. NEAR's mission was to fly within 35 kilometers of the asteroid Eros, closer than any spacecraft had got to an asteroid. If we were ever to fire a missile at the asteroid, we must be sure we can target the object effectively. NEAR began an extended orbit around the asteroid, sending detailed images back to Earth. These images will help to identify if the asteroid is made of a softer rock or the more destructive iron or metal type. This information will be vital to the people who are working on the defense against asteroids. High in the hills of New Mexico lies Los Alamos, the nuclear laboratories where Oppenheimer and his colleagues split the atom and designed the bombs that destroyed Hiroshima and Nagasaki. John Dale Salem works at Los Alamos as a nuclear scientist. He is also a world-renowned expert on the physics of asteroid deflection.
We plummet into the side of it just on the surface, set off the explosive, and it blasts material out of the asteroid. It isn't if there will be an impact, it's when there will be an impact. The effects are so global in nature that it seems like one ought to pay some attention to it.
There are two basic scenarios that they've been working on. Firstly, exploding a nuclear warhead some distance away from the asteroid, sending a shockwave which would deflect the asteroid off course. The second one is to explode a warhead on the asteroid itself, breaking it up into two pieces, which would then pass by either side of the Earth. Some are concerned that there are inherent dangers to detonating nuclear warheads in space.
If you actually get a nuclear device into space that is interplanetary space, there is practically no danger. The radioactive material is dispersed over quite a distance, and let's say interplanetary space is an exceedingly large volume compared to anything that we can think about here on Earth.
But even John Dale Salem recognizes that nuclear weapons shouldn't be the only method of deflection.
The general perception of a nuclear explosive on a rocket is a frightening one. It's frightening to me. And I would rather see an alternative discovered.
Even though asteroid research has made huge leaps forward in detection, some of those at the heart of the NEO programs still hold fears that one day an object may slip through the net.
One never knows what the next frame that we're looking at or the next observation we make is going to divulge, what is going to be there. So you're kind of walking on eggs all the time. It's like, we found this one and it's fairly sizable. I wonder how many others are out there that are much closer that we're not seeing.
Unseen menaces from space have always intrigued early science fiction writers. The threat of an asteroid impact was once popular science fiction that became science fact. But what about alien life forms invading Earth? Surely science fiction. In 1920, H.G. Wells wrote his famous work, War of the Worlds, a fictional account of advanced Martian invaders attempting to take over the world against the powerless humans.
This could be the beginning of the end for the human race. For what men...
Just as we are about to be overthrown, an earthly virus unwittingly stops the Martian invaders in their tracks. Avoiding bacterial contamination of Mars from Earth has been a scientific fact for NASA since 1974. NASA has recently announced a new schedule of missions to Mars. At the start of the next decade, they are planning to bring samples of the red planet back to Earth with an unmanned rover. NASA believes it is the only way they can conclusively prove that there was once life on Mars. But critics think that there is a theoretical risk of contaminating Earth with Martian microorganisms.
We cannot be gung-ho about returning samples of Mars to Earth because Mars is not the moon. It has all the elements necessary for life on Earth to live there.
I can imagine ways in which a simple microscopic organism can do damage on Earth. It could invade and cause havoc.
When Earth gets splashed by meteorites, Mars gets hit by debris. And bacteria can survive these kinds of natural transits.
Some fear that the Martian rock may harbor microbes and viruses that could cause illness and death on a scale that we have never seen before if samples were returned from the red planet. Like the Martian invaders in War of the Worlds, our immune systems would be defenseless against this bacteria. NASA insists they are more than aware of the potential problems in returning Mars samples to Earth, as NASA's Chief Planetary Protection Officer, John Rummel, is responsible for safeguarding us from alien bacteria.
The planetary protection program that NASA has focuses on avoiding forward contamination, which is the importation of Earth organisms to other environments in the solar system where they can grow and thrive, and to avoid back contamination, bringing any organisms that might be out in outer space back to the Earth without knowing about it.
His team of scientists safeguard the Earth and other planets from accidental cross-contamination of life-giving microorganisms. Planetary protection is a serious business. Every new interplanetary space probe has to be sterilized by these planetary protection scientists at NASA's Jet Propulsion Laboratory in California. The team are currently working on the next Mars rover project, scheduled for 2003. And while many people believe that the Martian environment cannot support life, recent research has proved life to be more resilient than we first thought.
We have found that life is just about every place that you look. If you look in areas on the Earth that you think it's too hot for living things are there. And if you look for where it's too dry, and it's been dry for hundreds and thousands of years, living things are there. So we find living things in a lot of different places that have the ability to hide out from tough conditions. And that's part of the reason that we have to have facilities that are set up for building our spacecraft to certain exacting standards, and then the techniques to make sure that we did it.
But as well as protecting the Earth from alien microbes, the planetary protection team must ensure that the spacecraft we launch do not contaminate other planets. If NASA is going to spend over $1 billion sending a probe to test for life on Mars, they have to be absolutely sure that they do not contaminate the red planet with life from Earth. Microbes can survive even the most extreme temperatures, so it's extremely difficult for the planetary protection team to spot any surviving microorganisms after the heat treatment. Currently, they are experimenting with new techniques for future missions. Intriguingly, they have gone back to basics for a potential solution with one of the most ancient creatures known to man, the horseshoe crab. This creature has very unusual blood, which clots on contact with tiny amounts of microbes and might be used to help identify organisms that have survived the sterilization process.
When this horseshoe crab blood comes into contact with even very small quantities of this, it clots up and binds this endotoxin material, and we can detect that clotting and are able then to see, using the horseshoe crab blood, that there's this small amount of earth microbe inside of this, water solution.
Without sterilizing the rover properly, the instruments could end up testing microorganisms that traveled with the spacecraft from Earth.
Remember the story in Winnie the Pooh about Pooh and Piglet going to look for a woozle? They were hunting a woozle because they saw footprints in the snow. And they went walking, and then they saw more footprints, and they thought there were more woozles. And they went on, and Christopher Robin was sitting in the tree looking down, and they were going around in circles and noticing their own footprints and thinking it was something else.
Creating false positive results is the planetary scientists' worst nightmare. Defending the Earth from alien bacteria may seem like a fanciful notion, but NASA has taken the concept very seriously since 1967. 2 years before the moon landing, NASA realized that there was a theoretical risk of contamination from moon rocks. When Armstrong and Aldrin landed on the moon, there was always the potential that moon dust could be toxic or contain harmful bacteria.
To protect against any possible lunar contamination, the astronauts put on airtight special garments before coming aboard the rescue ship. They transferred directly from the helicopter to a mobile quarantine van, in which they would be flown back to the Manned Spacecraft Center in Houston, Texas. Ahead lay 3 weeks of isolation, medical tests, and mission debriefings. Then visits to major cities of America and abroad.
But the planetary protection team soon discovered that moon rocks were completely harmless and sterile, and subsequent missions gave up the quarantining procedure. The prospect of life on Mars has been tantalizing scientists ever since the Viking mission to the Red Planet.
trip began in the summer of 1975. First one spacecraft, then another, launched toward Mars by Titan Centaur rockets, the beginnings of a voyage of exploration and discovery.
Bob Corkle was one of the original planetary protection veterans who worked on the Viking mission.
There were two spacecraft. Each spacecraft had an orbiter and a lander, and they flew locked together. We heated it up to the appropriate temperature that killed off the organisms on it. Then we attached the orbiter part of the spacecraft together with that clamshell, the outside of the clamshell, put it on the rocket, and then that was what was launched and went to Mars.
Viking remains one of NASA's most successful missions. At the time, they hoped to prove that life once existed on the Red Planet by conducting a series of remote experiments. The two unmanned spacecraft landed successfully several hundred miles apart and began to test the soil for signs of biological life. The two Viking landers sent the results of their tests to scientists back on Earth. With two probes doing identical experiments, it was thought that any positive results of life would be proof enough for the scientists. The big project for the planetary protection team is to prepare for the return of real Mars samples. But there are an increasing number of people that are opposed to this idea. The International Committee Against Mars Sample Return are against returning Martian soil, partly because some believe that the Viking results did indicate some sort of evidence of life on Mars.
People, scientists and environmentalists all over the world should be able to have a vote or a say in whether they think this thing should be brought back now or not.
Let's run the so-called...
The partial evidence came from a device called the Labeled Release Experiment, developed by Dr. Gilbert Levin at his company Biospherics Incorporated back in the early 1970s. To this day, he believes his experiment was successful.
The heart of the Viking mission was the search for life on Mars. The experiments were carefully selected so that they covered a range of possible types of Martian life. And it was stated at the outset that if life were detected on Mars, it was likely that only one of the three experiments would detect it.
The soil sampler scoops up its samples and deposits them in one of three chambers, which are, in effect, miniaturized laboratories, each one asking different questions.
Dr. Levin's Labeled Release Experiment was one of three different tests for life on Mars. Each test remotely examined the soil for signs of microorganisms, the building blocks of all biological life in the universe. While his experiment showed a positive result, one was negative and the other inconclusive. But after much deliberation, NASA decided that Levin's result was not conclusive enough to solve one of the great mysteries of our solar system.
It's a very logical experiment, brilliantly executed. And when we got to Mars, and that experiment was executed actually multiple times on multiple samples, the results showed some type of positive reaction.
I think the labeled release experiment showed that in two random spots, 4,000 miles apart on Mars, we got nearly identical positive responses indicating the presence of life, just as you would get on Earth.
There are now multiple schools of thought on the results of Dr. Levin's experiment. One is, by perhaps the majority of scientists in the community, is that we saw a reaction product of that experiment that is non-biological.
Undeterred, Dr. Levin reanalyzed his data from the Labeled Release Experiment. In 1997, after years of further research, he concluded that he did find evidence of life, creating uproar in the scientific community. The controversy continues to this day.
The Viking results indicated the presence of something. For them to tell you that no evidence was found is not only incorrect, but it is unscientific. Evidence was found, not proof, evidence. And the evidence needs to be elucidated on further.
Levin claims that his evidence for life on Mars, however debatable, warrants an extremely cautious approach to sample return.
We have only one Earth, and if there is even an infinitesimally small chance that we could do damage to it, we're not warranted to undertake that risk. So I say let's eliminate that risk, which can be conveniently done. And to say that it's unlikely that microorganisms from Mars could do damage here is really not based on clear, cold logic.
But have alien bacteria already caused havoc with life on Earth? Some evidence now suggests that it took 2 million years for the dinosaurs to become extinct after the effects of the asteroid impact. Some feel that the meteor could have carried with it an alien virus that caused the dinosaurs' extinction.
This meteor brought with it some forms of life that infected these many species and wiped them out. And I don't know how we can make one conclusion or the other.
There is evidence for a pattern of hyperdisease, a species-crossing disease. So it cannot be discounted at this time that debris from other worlds does not infect our planet, because we do go through these extinction periods, and we don't know what causes them exactly yet.
The International Space Station is a permanently manned spacecraft in orbit around the Earth. Its main purpose is to act as a scientific laboratory in space. The International Committee Against Mars Sample Return believes that it would be safer to test the samples there.
The point is, sure, the Mars Sample Return mission may come back. It may not cause any harm at all. It may go off perfectly. But if it does not, and there is a global problem, obviously the Martian microorganisms, if there are any, would not recognize international boundaries.
But NASA don't agree with ICAMSA's proposition.
The potential for doing an adequate biological and chemical analysis on the space station is very low, both because of our inability to put all the right instrumentation and expertise up there. There's going to be a limitation on how many people could do the work if we were to put it on space station.
But some scientists dismiss the idea of Mars samples posing a risk to life on Earth. Dr. Robert Zubrin, Mars expert and chairman of the Mars Society, believes that fear of contamination is misplaced.
The notion that Martian samples could represent a hazard to the Earth's biosphere is completely preposterous. The disease organisms are specific to their hosts. Humans get diseases from other humans, sometimes from other mammals, occasionally from birds, but never from trees. No one I know has ever caught Dutch elm disease, and trees don't get the measles.
But a recent study by scientists on a small Mars meteorite discovered in 1984 indicated potential signs of fossilized microorganisms in the Mars rock. Perhaps showing that Mars organisms pose no threat to humanity after all.
If Martian rocks were dangerous, we've already got the disease, because we get about 1,000 pounds of these things landing on Earth every year. One of them hit a dog in Egypt in 1911, okay, Nakla. And so if the Red Death could come from Mars, it already has. And if Earth could contaminate Mars, it already has, because when Earth gets splashed by meteorites, Mars gets hit by debris. And bacteria can survive these kinds of natural transits.
NASA don't expect to send a Mars sample return mission until towards the end of the decade. Before then, the debate whether there is life on Mars will continue. And until real live Mars samples are returned to Earth, we will not have conclusive proof of life on other planets. There are a lot more immediate problems facing scientists who are concerned with the dangerous effects from space on the Earth's biosphere. Our planet is under constant threat from invisible dangers emitting from our own life source, the Sun. The solar wind, a gas comprising primarily of electrons and protons, is periodically ejected into space towards our planet. It is held at bay by the Earth's vast magnetic field, which deforms under the onslaught of this solar gale, like an enormous tent being buffeted by a desert storm. The solar wind compresses the Earth's magnetic field, spiraling down to the Earth's polar regions, creating the northern and southern lights. Generally, this constant stream is not a problem for Earth until the Sun erupts with a phenomenon called a coronal mass ejection, which is so powerful that it overwhelms the Earth's magnetic field.
The space environment is probably the harshest environment anybody will ever encounter.
These very high energy particles can penetrate through spacecraft into computers and computer chips.
If you're an electric power utility, the only alternatives you have are either to watch your huge megawatt transformers be destroyed or to take them off the grid.
They can also damage satellites, and they represent a substantial radiation risk to astronauts in space.
Solar storms existed before the dawn of man, but it wasn't until we took our first step into space that it became a real threat to human life.
Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engines running. Commit. Liftoff.
Apollo 12 lifted off in the driving rain.
NASA knew that the threat from solar storms was a problem for their astronauts and had planned several emergency contingencies. But they were hampered by the primitive solar forecasting techniques available in those early days.
Just, I believe, about a week after one of the Apollo moon landings, there was a coronal mass ejection and flare of such size and such an enormous particle event that had astronauts been on the lunar surface at the time, they probably would have received a lethal dose of particle radiation.
Now, there were mission rules about how much radiation you could have and all that sort of thing. We also knew that the radiation protection in our suit wasn't much. It was more in the lunar module, and it was more in the command module, and if you turned the command module towards the sun, the back end towards the sun, you even had more. So we'd thought about all this a lot, but I'd have to say, as I walked around the moon, I couldn't have cared less about it.
These days, modern technology allows the scientists to predict solar storms with far greater accuracy. Solar storms are monitored by the Space Environment Center in Boulder, Colorado, the worldwide alert station for solar radiation. The space weather forecasters work in shifts around the clock, monitoring the sun's activity.
Space weather for the next 72 hours is expected to be minor to moderate. Geomagnetic storms reaching G2 level are expected. Solar radiation reaching S1 level is possible. Radio blackout reaching R1 level is possible. Special support is currently being provided for the shuttle. Let's launch STS-106.
Larry Coombs is one of the forecasters, helping to warn the world about sunstorms.
The forecaster is looking at all the information that's coming in, solar wind information, the various images of the wavelengths of the sun that we have, and he's taking all this information and coming up with a prognosis of the space weather for the next 24 hours to 3 days. The space shuttle is up at this time, so he's also keeping prepared to brief the shuttle mission throughout the day.
The solar storm forecaster's role in warning astronauts of space weather activity will be absolutely critical in the next 5 years. NASA are planning to launch an average 8 shuttle missions a year over this period, as a huge construction site is established in orbit around the Earth. The International Space Station will become the equivalent of a space skyscraper. Astronauts, like high-rise construction workers, will spend hundreds of hours working in the potentially lethal conditions of space, relying on their spacesuits for protection.
The space environment is probably the harshest environment anybody will ever encounter. The temperature extremes go from minus 250 degrees below zero to plus 250 degrees Fahrenheit above zero.
The spacesuits are an immense feat of engineering, costing over $12 million each.
What I'm connecting now is my liquid cooling and ventilation garment.
You can see some water flowing through there, see some air bubbles going through there. This provides my cooling.
The suits are cleverly designed to protect the astronaut from the harsh environment of space, with one exception: sunstorms.
If you have a large solar storm, radiation, you would not go out inside the suit. You'd be more protected inside the shuttle.
Dangerous energetic particles capable of killing an unprotected astronaut arrive less than 1 hour after the sighting of a solar flare. The ability to be able to predict these eruptions is their highest priority. Before an astronaut can embark on a spacewalk, solar activity has to be at a low.
We're in constant communication with the solar environment folks around the country, around the world, that observe the sun, that predict solar activity and observe events that could lead to radiation in Earth orbit.
Last week when the astronauts were up, the activity was at a low, so that was good. If the activity had increased, we would have been again in touch with NASA and letting them know what's going on. If they're inside, there's certain precautions they can take. There are certain areas of the shuttle that's shielded more than others where they may reside while the storm kind of passes. If it's extreme, then they may even consider changing their orbit or even coming back, but that would have to be a very extreme case.
The Space Environment Center is able to predict solar storms with far greater accuracy since NASA launched their SOHO satellite. The satellite acts as an early warning system and sits in space midway between the Earth and the Sun. SOHO is operated by NASA and the European Space Agency at Goddard Space Center, Maryland, Washington, D.C. There they download data and live images of the Sun for analysis.
We regularly send messages to NOAA's Space Environment Center when we see what appears to be an Earthward-directed coronal mass ejection. They compare that with their other sources of data, and if they agree, they issue warnings to their various customers. In general, there are very few effects of space weather that are not avoidable if people have sufficient warning.
The ability to predict solar storms has become more critical to maintaining hundreds of satellites and vast global electricity grids humans so depend on in the modern world. When one of the sun monitoring satellites picks up an increase in solar activity, the forecasters are put on full alert, contacting power stations, satellite operators and navigators to warn them a storm is on its way. A sunstorm is not something a human on Earth can see or feel, but the results can affect daily life.
Good morning, sir. This is Court Williamson, Space Weather Operations in Boulder, Colorado. Following warning has been extended. I have a magnetic K index of 5, warning. Valid this date at 1500 hours. That's right, it's a warning, sir.
What happens is this energy hits the Earth and it's coming in as a pretty much a direct current. And of course we use alternating current when we're sending out the product itself. And power companies will download or possibly switch off different grids that may be affected.
If there's not sufficient warning, the huge oil baths in which these turbines spin can burst into flames. So if you're an electric power utility, the only alternatives you have are either to watch your huge megawatt transformers be destroyed or to take them off the grid.
Sometimes those warnings have come too late. During the last solar max, the 11-year cycle when the sunstorms are at their highest, there was a huge eruption from the sun, which was missed by the solar weather forecasters. In the early hours of the 13th of March, 1989, the solar storm arrived. The Earth's atmosphere expanded as it tried to absorb the radiation, buffeting satellites and knocking them out of position. Communication systems around the world malfunctioned. Within minutes, the electricity grid in Quebec, Canada, took a massive hit, causing blackouts across the province.
All 5 lines from James Bay went out at the same time. Hydro isn't sure why the lights went out. They don't think it was equipment failure. They suspect something more unusual.
This event was a watershed for solar storm forecasters. The Soho launch in 1995 was designed to prevent a reoccurrence of the Quebec power failure. But on June the 24th, 1998, during routine maintenance operations, the team lost control of this most important satellite, leaving the Earth vulnerable again to the destructive powers of the Sun.
The spacecraft was in a flat spin so that its solar panels were pointed not towards the Sun, but 90 degrees away.
This left the frozen satellite with no power, drifting in orbit around our solar system. Efforts to establish contact with Soho failed. For 6 weeks, there was silence, as Soho refused to respond to the signals sent by the team back on Earth to revive it.
We were continually sending signals through the Deep Space Network to tell Soho to communicate back to home.
It was a big problem for solar weather forecasters. Without Soho, they had lost their early warning system that they had become so dependent on. Just as they thought all was lost, on August the 3rd, contact was suddenly re-established as the satellite's changing orbit gradually revived the frozen satellite. After a lengthy process of thawing out, the pictures of the Sun were again transmitted back to Earth. More needs to be discovered and understood about the threats from space if man is to maintain our modern communications-based civilization.
As we use space, as we rely on it more and more, as we perhaps explore to other planets, the need to monitor, predict, understand the space environment will certainly increase.
We become every day more and more dependent on things that space weather can disrupt. So we have to be able not only to predict and understand what the effects of space weather are, but how to mitigate them.
Protecting our planet is a vital part of the safety net we need to have as we bring back these priceless pieces of Mars.
I can imagine ways in which a simple microscopic organism can do damage on Earth.
I consider the asteroid search to be, in a way, an insurance policy. It's well within our capability to go out and find where all of the big ones are, and we should be doing that.
For many thousands of years, mankind was unaware of the vulnerability of our planet. We now know that the solar system that created us could also one day destroy us.